Hello, and welcome to the session on terminating decimals and recurring decimals. If you have not had the opportunity of watching the earlier session on types of numbers, in this session, we will recap what we learned about terminating decimals and recurring decimals. Further on, we'll also learn how to convert terminating decimals into fractions and also how to convert recurring decimals into fractions and vice versa. So let's begin then. What are terminating decimals and recurring decimals? Okay, when do we get recurring decimals? Okay, if you remember from the earlier session, we had done this. Okay, if the denominator of a fraction in its simplest form has only prime factors 2's and 5's, we'll end up getting terminating decimals. For example, 20 consists of 2's and 5's, right? It's 2 squared times 5. So that's why we get terminating decimal. 1 over 20 is 0.05. So it terminates at 5. Likewise, 43 over 8. Because 8 consists entirely of the prime factor 2, 2 cubed is 8. Okay, we end up getting a terminating decimal, which is 5.375. So the decimal terminates at 5. Similarly, anything over 10, because 10 consists of 2 and 5, it entirely consists of prime factors 2 and 5. We end up getting a terminating decimal, which is 23.7, right? On the other hand, if the denominator has a prime factor, which is anything other than 2 or a 5, we get recurring decimal, right? 1 over 3, for example, is 0.3333, which means zero point 0.3 recurring. 68 over 15, because 15 consists of 5 and 3, okay, that makes it again recurring, 4.5333. So the digit 3 recurs. Likewise, 131 over 11 gives you a recurring decimal, right? Because 11 is neither 2 nor 5. So we get recurring decimal, which is 11.909090. So if you should have remembered this, okay, from our earlier lesson, okay, if the denominator consists entirely of prime factors 2 and 5, we get terminating decimal. If the denominator consists of prime factor anything other than 2 or 5, we get recurring decimal. Okay, for example, any number over 6, because 6 consists of 2 and 3, it will give you a recurring decimal because of that 3 in the denominator. On the other hand, a number divided by 40. 40, if you know, the prime factors are 2 cubed times 5. It entirely consists of 2's and 5's, so we get a terminating decimal. However, it's not as simple as it looks like. Okay, remember the definition clearly states in its simplest form. Now that is the key. For example, let's take an example here. 9 over 6. Now you may believe because 6 consists of 2 and 3, because of the 3, it will end up being a recurring decimal, right? However, 9 over 6 is a fraction which is not in its simplest form. If I reduce it into simplest form, which means if I divide both numerator and denominator by 3, I would end up getting 3 divided by 2. And now in the simplest form, the fraction doesn't have a denominator which has 3 in it, right? It entirely consists of 2, which means this is a terminating decimal, which is 1.5. So make sure you understand that bit about the simplest form, the fractions being in its simplest form or in their simplest form, right? Secondly, okay, one little thing about recurring decimals, 0.3333. So instead of writing 3333 infinitely, one way of writing it is putting a dot over 3. Okay, the dot indicates that that particular digit, the decimal digit, will recur or repeat, right? Likewise, if we have 4.5333, 5 is not recurring, but 3 is. So we put a dot over 3, 4.53 and dot over 3, indicating that that 3 is the only digit which recurs. 5 doesn't recur, 3 recurs. Okay. If we have more than one digit recurring, for example, 11.909090, you put the dots over both 9 as well as 0, indicating that 9 and 0 are the recurring digits, right? Perfect. Now, let's know some basic fraction which will help us to convert, okay, fractions into recurring numbers. So these are the basic fraction which you should know. 1 over 3, 1 over 6, 1 over 9, and 1 over 11. Right? So let's first find out their values using the normal division, okay, the long division as we know. So 1 divided by 3, since 1 cannot divide 3, 3 cannot divide 1, we have a 0, which makes it, right, 10. And 3 goes into 10 three times. So we get 9 with a remainder of 1. And now you realize that once you get the remainder of 1, the second step will keep repeating. And hence the digit 3 will keep recurring. Okay, this is no rocket science. It's the normal long division that we do. Okay, so 1 over 3 is nothing but 0.3 recurring. Let's understand what is 1 over 6 now. By the same logic, okay, 6 cannot divide 1, so we put a 0, right? So that makes it a point and a 10, right? 0 point and a 10 in the denominator. 6 goes into 10 one times, leaving a remainder of 4. Okay, 4 becomes 40. 6 goes into 40 six times. 6 times 6 is 36, leaving a remainder of 4 again, which means the third step will keep repeating here on. Okay, which means the digit 6, which we got earlier, will keep recurring. And hence 1 over 6 is 0.16 with the 6 recurring. Let's find out what is 1 over 9. Okay, the first step is the same. 9 doesn't divide 1, so we put a decimal and that makes it 10. Now 9 goes into 10 once, leaving a remainder of 1. So that second step will keep repeating here on, which means 1 over 9 is nothing but 0.1 recurring. And finally, what is 1 over 11? Okay, 0 point. Okay, now you would realize that 11 doesn't divide 10 either, which means we need to put one more 0, which makes it 100. And 11 goes into 100 9 times. 9 times 11 is 99, leaving a remainder of 1. The second step now repeats here on, which means these two digits will keep on recurring, 0 and 9, which means 1 over 11 is 0.09 recurring. Both the digits are recurring. Now we need to know these four basic fractions and their recurring decimals so that we can find many other recurring decimals. For example, if I have a 5 over 9, okay, we know that it's a variation of 1 over 9 because 1 over 9 is 0.1 recurring. 5 over 9 is simply 5 times that fraction. So your answer will be 0.5 recurring. It's as simple as that. Okay, let's look at a variation of 1 over 11 now. Because we know 1 over 11 is 0.09, both digits recurring, 7 over 11 will be the seventh multiple of that fraction, right? Seventh multiple of 1 over 11. And hence your answer is 9 times 7, 63 recurring, 0.63 recurring, right? Did you understand the trick? So knowing those four basic fractions can help you to find many other fractions. Okay, how do you find the recurring decimal for those fractions? Okay, now what about this 13 over 9? Now here's where you convert 13 over 9 into a mixed number. As you know, 13 over 9 is 1 plus 4 over 9. No rocket science here, right? If I convert into a mixed number, it will be 1 4 over 9. Okay, now let's leave 1 to its own. 4 over 9, as you know, is the fourth multiple of 1 over 9. So it should give you 0.4 recurring. So 1 plus 0.4 recurring is nothing but 1.4 recurring, right? So these are some of the ways in which you can use some basic fractions to find out the values of other fractions. Okay. Now let's look at the extreme left. We know 1 over 3 is 0.3 recurring. So 8 over 3, okay, which is nothing but 2 plus 2 over 3, right? 8 over 3 is 2 plus 2 over 3 in mixed number. Let's leave 2 on its own. 2 over 3, as you know, is the second multiple of 1 over 3. So it will be 0.6 recurring. So your answer will be 2 plus 0.6 recurring, which is 2.6 recurring. Perfect. So did you understand the trick here? So know those four basic fractions. 1 over 3 is 0.3 recurring. 1 over 6 is 0.16 recurring with only 6, the digit 6 is recurring. 1 over 9 is 0.1 recurring. And 1 over 11 is 0.09 recurring with both 0 and 9 recurring. Now, here are some special cases of recurring decimals. Okay. If we have a single digit number, okay, divided by 9, then that digit will always recur. Okay, for example, a 7 over 9. Because I know 7 over 9 is 7th multiple of 1 over 9, it will have the digit 7 recurring. So 0.7777 and so on, 7 recurring. Likewise, 4 over 9 is the 4th multiple of 1 over 9, right? So it will have 0.4 recurring, right? Now, what is interesting is this property can be extended to more than one digits. For example, 37 over 99. Okay, because there are two digits 37 and 99, there are two nines. Both the digits 3 and 7 will keep repeating or recurring, I would say. So 0.37 recurring. Both 3 and 7 are recurring, right? This is a very handy property. Okay. How about 752 over 999? Because there are three digits 752 and there are three nines. Each of the three digits 7, 5 and 2 will recur. So it will be 0.752. All three digits are recurring. Now, to express 0.752 recurring, you need not put the dots over each of the three digits. Okay, all you could have done is you could have put a dot over 7 and a dot over 2. Okay, that means anything in between these two, including both of them, will keep repeating. Okay, what about 17 over 33? Now, this doesn't have nines in the denominator. But is it possible to get nines in the denominator? Yes, because if I multiply 33 by 3, I'll get 99. So what I do is I convert 17 over 33 into its equivalent fraction with 99 as the denominator. For that, I need to multiply 17 and 33 both by 3. So I will get 51 over 99. And this is like my old fraction, which can be converted into a recurring number. Because we have two digits 5 and 1 divided by 99, both the digits 5 and 1 will keep recurring, which means 0.51, both 5 and 1 recurring. How about 8 over 111? Now, once again, is it possible to convert 111 into 999? Yes, by multiplying that by 9. For that, I need to multiply the numerator by 9, right? So if I multiply both numerator and denominator by 9, I'll get 72 over 999. Now here I have a problem. 999 has three nines, but 72 is only two digits. So what will recur? Well, ideally, as per the property, the number of digits in the numerator and the number of nines in the denominator must be equal. But in this case, they are not equal. But is it possible for me to convert 72 into a three-digit number? Yes, right? 072, which means the answer will be 072 recurring. Okay, all three digits 0, 7, and 2 are recurring. Because 72 was a two-digit number. To make it a three-digit number, I had to add a 0 in front of, okay, 7. So I get 072 as a three-digit number, and all the three digits will now recur. Well, now we can use this property to do the conversion in the reverse form, which means if I'm given a recurring decimal, we can easily convert it into a fraction. For example, 0.5 recurring, we all know is 5 over 9, right? 0.2 recurring is 2 over 9. 0.43 recurring is 43 over 99. Now we are doing the other way around. Okay, how about converting a recurring decimal into a fraction, right? 0.74 recurring, because there are two digits 7 and 4 recurring, we need to have 99 in the denominator, 74 over 99, right? 0.157 recurring, because there are three digits recurring. Now you know the trick, right? It's three nines in the denominator, so 157 divided by 999. Okay, how about this? 0.023, all three of them recurring, 0, 2, and 3. Basically, it is 23 over 999, right? Because if I add a 0 before 23, I would still end up getting 23. Because there are three digits recurring, it will be 999, right? Now, there's a slightly different way of getting the same result, okay? And it is important to understand that method because what happens if not all the digits are recurring? Okay, in this case, if you look at the examples carefully, all the decimal places, okay, be it 1, 2, or 3, all of them are recurring, right? So let's understand the method, uh, okay, of solving this in a different way so that we can always convert any other format of recurring decimals into fraction. Okay, even if not all the digits are recurring. Okay, so let's look at the method. Let's try and convert 0.43 recurring into fraction. Okay, so for that we need to first assume let 0.43 recurring be a number x, right? Now, as you know, x is nothing but 0.434343 because it is recurring. These digits will keep repeating. Because there are two digits which are repeating, okay, we multiply x by 100 first. Why 100? Because there are two digits repeating, 100 has two zeros. This will shift the decimals two places to the right. You know, when I multiply a number by 100, it simply shifts the decimal two places to the right. So I'll get x, 100x on the left hand side because 100x is 43.43 recurring, right? Remember, the decimal has shifted two places to the right. So I will get 43.43 recurring, right? And the original number was x, which is 0.43 recurring. So the interesting thing is if I subtract both of them, okay, on the left I'll get 99x, and on the right you will get a good number, which is 43. Now, how did that magic happen? The reason being, we have a 43.43 recurring in the decimal, take away 0.43 recurring in the decimal. So the 43 recurring in the decimals, okay, when I subtract, they get cancelled and I'm left with 43, right? And hence, x is nothing but 43 over 99, right? So this is how we can convert a recurring decimal into a fraction. Let's take one from the right. Okay, let's say 0.157. All three digits are recurring. Now, how many digits are recurring? Three. So what do you think we should multiply x by? You guessed it right. Okay, 1000. Because 1000 has three zeros, multiplying by 1000 will shift the decimal three places to the right. So 1000x will then be 157.157 recurring, right? Then you take away both the numbers and you get 999x. Remember 1000x take away 1x is 999x equals to 157 because that recurring decimal get cancelled. 157 recurring gets cancelled. So 999x equals to 157 or x equals to 157 by 999 is the same result as you can see which we achieved earlier, right? So at the end, we'll look at how to convert recurring decimals into fractions if all the digits are not recurring. Okay, for example, look at this number 0.27 recurring, only 7 is recurring, 2 is not recurring, right? Now, the method that we just saw earlier, the x method, okay, will help us to solve this one. So first, let x be this number, okay? Because there are two digits, we'll first multiply this by 100, right? So 100x will be 0.27. Okay, 100x will be 27.7 recurring. Remember, only digit 7 is recurring. So 27.7 recurring. Now, if I subtract this from x, okay, you realize that the decimals won't cancel because 100x has 7 recurring, whereas x has 0.2 and 7 recurring. So the decimals won't cancel. So we need to do one more step here. Okay, we need to shift the decimal between 2 and 7. Right now, the decimal is before 2. What should I multiply by to shift the decimal between 2 and 7, which means we need to shift the decimal one place to the right. So the number that I should multiply by is 10x. Right? Now you'll understand why did I do that. Okay? Because now 10x will be 2.7 recurring. Remember, the decimal has shifted between 2 and 7. So the 7 is still recurring, but now it is 2.7 recurring. Right? Now if I subtract both, you'll realize that on the right hand side, the 7 recurring will get subtracted because the decimal part is 7 recurring. That will get subtracted. On the left, we have 100 take away 10, which is 90x. And on the right, we have 27 take away 2, which is 25. And the 7 recurring got subtracted, right? So x will then be 25 over 90. Did you get that right? Okay, let's try one more example of this kind. Okay. 0.758, where 58 is the are the only digits which are recurring. Okay, how do I convert them into fraction? Let's see. Let's first assume that number to be x. The first step is simple. Because there are 3 digits, we multiply that by 1000. So we get 1000x is equal to 758.58 recurring. Okay, remember only 58 is recurring, so 758.58 recurring. Now the next step is to separate the recurring and the non-recurring part, which means I need to shift the decimal between 7 and 5, right? So that the recurring and the non-recurring part gets separated. Because I need to shift the decimal one place to the right, I multiply x by 10. So now 10x will be 7.58 recurring, right? And if I now subtract the two, on the left I'll get 990x, and on the right I'll get 751, because 758 take away 7 is 751. The decimal places 5, 8 recurring, okay, will get cancelled out as you can see when I subtract. So x will then be 751 over 990. So you now know how to convert any recurring decimal into fraction. Okay, remember this method of x. Okay, now just as a check, okay, because the examiner would expect you to write the steps and show you're working in this format. However, I have a little trick up my sleeve. Okay, you can always verify your answer with this little trick. Okay, look at this carefully. So we now know there's two results. Okay, now how do I get these two results without doing any working or any calculation? Okay, remember this formula. The numerator of your fraction will always be the complete number without any decimal minus the non-recurring number without any decimal. Okay, I know you, this is mumbo jumbo and it's too much of a jargon. So let's understand this carefully. If you look at the decimal 0.27 recurring, where 7 is recurring, the complete number without any decimals is 27, correct? Because 2 and 7, complete number without any decimals is 27, which is a non-recurring number. Okay, the recurring number or digit is 7. So the non-recurring digit in this case is 2. So you write 2 without any decimal. Did you get? That's your numerator. So 27 minus 2, remember, is the 25, which is the numerator of your answer. Let's look at it for the second example, okay? 0.758. So what's the complete number? Okay, it's 758. What's the non-recurring number? In this case, it is 7 because 5 and 8 are recurring. So 7 is the non-recurring number. And hence, your numerator, as you can see, is 758 minus 7, which is 751. Did you see that? Now let's get the denominator sorted. Now remember, the denominator will only consist of nines and zeros. Okay, none other digit, nines and zeros. How many nines and how many zeros? Well, the rule is you need to put as many nines as the number of recurring decimals and as many zeros as the number of non-recurring decimals. Simple, right? Nines equal to recurring decimals, zeros equal to non-recurring decimals. For example, in 0.27 recurring, where 7 is the only digit recurring, how many digits are recurring? 1, which is 7. So you put 1 9, and how many digits are non-recurring? That's again 1, which is 2. So 1 0. So you put 1 9 because one digit is recurring, which is 7, and 1 0 because one digit is non-recurring, which is 2. Right? So the denominator of your answer will be 90. Look, what about the second fraction? Okay, how many digits are recurring? 2, 5, and 8. So put two nines. How many are non-recurring? 1, just 7. So you put 1 0. So your denominator is 990. And you got the same answer and you never did any calculation, right? But remember, as I said, the method that we saw earlier, where you equate the decimal number into as x, that's the proper method of solving, and the examiner would expect you to solve by that method. However, you can always use this method to check your answer. Okay, check your calculations basically. Okay, and this is a really good method to get the answer real fast, right? Well, that's the end of this session. Okay, I will once again recap what we learned in today's session. Okay, today we learned, okay, the difference between terminating decimals and recurring decimals. and how do you convert terminating decimals into fractions, and also we learned how to convert recurring decimals into fraction. I hope you enjoyed today's session, okay, and you have a lot to take away from today's session. Thanks a lot.